of some Postgres cluster on Kubernetes. So, a few words about me. I spend a lot of time chasing to achieve 100% availability. But now I built an observability tool that try to turn telemetry data into answers. What's happening right now in your infrastructure and how to fix issues to make it available again. So, as you know, any database is a crucial part of any infrastructure. So that's why we should care a lot about availability, about disaster recovery, backing up, upgrading, and so on. So it can be done in many ways in a company, like growing your internal DBA team, or maybe hire an external DBA team. But the most popular case these days is for small and medium business is to use database as a service offerings like Amazon RDS or Google Cloud SQL. And it's pretty useful solutions, but there is a thing, vendor lock-in. So, and business doesn't like vendor lock-in because of ownership of the data and maybe to be able to migrate your data between clouds and so on. So, and what if we want to build something like cloud managed databases, but without this vendor lock-in? So, from my perspective, it should be an open source solution. Because only in this way it can eliminate vendor lock-in. So it have to contain a lot of automation to provide us with the same level of service like Amazon RDS does. So, and Kubernetes here is a game changer in meaning that can bring us unified API to be able to manage infrastructure by the cloud. Previous speakers told us a lot about operators, so I don't see any need to repeat it again and again. From my point of view, operators on Kubernetes can give us the same level of automation, the same level of reliability comparing to cloud managed database offerings. So, and in this talk, I want to talk about availability because no Kubernetes operator for managing databases can guarantee 100% availability. So let's see, and I would use my lab. So it's a small Kubernetes cluster and a Postgres cluster deployed on it. I used Postgres Operator by Zalando. I will use Chaos Mesh for failure injection. So, and I use Coroot and its agents for observability. And let's start. So the first failure scenario is isolating one of replicas. So we have an application that works both with primary and replicas. So let's see how I just put there a specification of Chaos Mesh to maybe you will want to introduce to reproduce it. But I have recordings of this failure scenario. Here we have an application and database cluster. One of them is primary, DB2 is primary, and 2 replicas. So they work with Kube API server as a distributed configuration store. So this chart is a response time histogram of the application app that use database as a primary storage. And this is just status of each container in the cluster. So let's see. Here, let's wait for dance. So here we have one of containers goes down. We can see that this is DB main 0, and as we can see here, there are a lot of errors because of the application cannot connect to that replica, and as we can see, downtime lasted around 30 seconds. So what's happened here? Each container of Postgres is managed by Percona. This is a tool also developed by Zalando company, and it maintains each instance and literal action, and it's in charge of literal action here. But here we fancied only one replica, so we had a lot of errors, but the outage lasted 30 seconds because after that Kubernetes handled the situation and removed this replica from load balancing. So the more complicated case, when we will isolate the primary instance. So let's do it and see what's happened. It's the same infrastructure, same environment. What's happened here? Here, one of instance goes down. It's previous primary instance, and we can see that now primary cluster elected the new primary instance here. So there are a lot of errors because of this. So an outage lasted 27 seconds. So what's happened here? Percona acquires a lock in API server for electing leader for 30 seconds. So it must refresh its logs in every 30 seconds. So when we fenced the primary, it took near 30 seconds to determine that our primary is not available. So new literal action took a few seconds after the cluster detected that the previous leader is not available. In this scenario, I want to isolate one replica only from master. So we fenced not whole replica, but we just only cut connection between replica and the primary. So let's see. As you can see, replication lag started growing, but our application feels bad right now because a lot of errors. So what's happened here? I added a freshness check into my test application just for showing that the data between has a gap between updating data on the primary and on the replica. So, and Percona's health check used by the Postgres Operator readiness doesn't check the lag between between the primary and replica, and that's why the Postgres operator cannot handle the situation automatically. So the next one, I added connection pooler for primary instance. So let's see what if we isolate one pooler from the Postgres itself. So let's run. We can see a lot of errors again. And from application's point of view, we have a lot of errors, unable to connect. Such a scenario cannot also be handled automatically because health check, that Kubernetes check availability of PG bouncer in this case, is not checking connection between PG bouncer and Postgres. So, but as you know, this a complex network partitioning has very few chances to occur in real life. So, and one bonus track, we will perform major upgrade of Postgres cluster just under the load. So, and before we play this scenario, few main steps how operator performs major upgrades. Initially, the operator initiates rolling update, means every container should be restarted to change the desired Postgres version, and upgrade itself is not started yet. So then, when operator change the desired state on the replicas, it initiates a switchover, which means planned failover. So it promote one of the replica to primary. So and then we will have a total downtime of the cluster during the upgrade. So let's see. As you can see here, cluster has 13.7 version of Postgres. Let's start and see. First replica is done. The second one, switchover. And upgrade has started. That's it. First replica, the second one, switchover, and then it's upgrade itself. And now the version, wait. The version is 14.4. So as I mentioned, the initial rolling update took 10 seconds, and the downtime due to upgrade itself took 22 seconds. So, but in my lab, it was a pretty small database. So the actual duration of the downtime depends on disk performance, network throughput, and database size. So that's it. But now we can understand the behavior of the operator in such failure scenarios. So some takeaways, as I can see here. Kubernetes operators can be considered as a real alternative to manage databases by cloud vendors and so on. It's really good to see what behavior of the managing software you can expect before running it in production. And chaos testing tools are pretty useful here. Also, distributed database are pretty complicated. So we need to, and as you could see, there are a lot of possible scenarios where automation provided by the operators cannot be handled by them. So, and if you want to improve visibility of your system, you can try Coroot. It's really easy to install and free and open source, truly open source license, Apache 2. So, thank you. If you have any question, feel free to reach out to me. Yeah?
Thank you. I want to ask, can I use Coroot for other applications such as MongoDB or MySQL, for example?
Yeah, you will see basic resource metrics, network metrics like network latency, but we don't provide you with MongoDB specific metrics yet, and only Postgres and Redis. But without such instrumentation, it will be very, very helpful because, for example, our agent can parse logs right on the node and provide you with extract repeated patterns from your log. So it can be helpful without this instrumentation.
Thank you.
And you showed the demo, and in the demo I saw that you get the data almost every second?
Yeah.
So it's like default for Coroot that it gets the data metrics?
It depends on, Coroot uses Prometheus for storing
okay.
metrics, so you can choose any script interval you want. So Coroot can proceed from 1 second resolution to...
Okay, so Coroot kind of depends on what I have in Prometheus.
Yeah.
So it doesn't, okay, got it. Thank you.